Alright guys, I think we're up and running. Kind of a late start here. Let me get all our windows moved around, and I don't know what happened. I was out running some errands earlier, and I came back and I had Sony Vegas crash on me while I was rendering the time lapse, but looks like we kind of pulled things together okay. Alright, you saw we had a little bit of altocumulus out there. That was in that time lapse, and maybe I can pull that up real quick. There it is. And you can kind of distinguish that because of the cellular elements, and there's just a little bit of shading on the bottom side of those clouds. And what's causing that? Well, here's the satellite imagery, and we can kind of distinguish two different types of air masses here. Let's see. Hang on, I'm trying to get rid of that overlay. There we go. Now you can see a little bit better. But you can see a bit of tropical air to the south. At least it looks a little bit tropical. It looks like maybe some cumulus elements there. This is in the area between Monterey and Laredo. And then north of that, we've got clear skies. And we know we've had north winds come through that area. And in between, a little bit of an area of cloud right here. So this could be a good setup for isentropic lift, and that's essentially overrunning when we have the cold front move southward. And though we might have north winds behind the front, aloft, we might see south winds over that, and that will force air to rise. And if the humidity of that air mass is high, you're going to get clouds and possibly rain. So let's check out the weather pattern first before we get into that. This is the NAM 3-hour, 6-hour forecast here. And this is thickness and isobars. So we can see on the west coast there's one cold front trying to come in just off the Northern California coast. Not much going on in between, maybe a little bit of a weak lee side low. High pressure over Missouri there, and you can see cold air advection on the east side and a little bit of warm air advection on the west side. And down to the south, looks like we've got a cold front kind of sitting like that. And that's a reinforcing shot of cold air that we had come across Texas earlier today. So we can see that front is definitely down there, and we do have two different types of air masses. We got the tropical stuff down in Mexico and the fresh polar stuff in Texas. So this is a good starting point to look at the soundings, because we're going to look at Fort Worth, and we know that that's in the polar air north of the cold front. So here's the sounding from earlier today at Fort Worth, and rising, or the top of the chart going up, is height, and going to the right is temperature or increasing moisture. The moisture line is way over here, temperature line way over here. And we probably should do a SKU-T workshop here, maybe in the next couple of days, or next couple of weeks, depending on how my time works out. But where the two lines come close together, this is very high humidity and possibly cloud material. And we can see that the base of that is at about the 850 millibar level, which is about 5,000 feet high, and the top of that is up here at about 14,000 feet. So we're going to expect kind of like a mix of stratoQ and altitude in that mid layer. And down below that we see a frontal inversion. The temperature falls very gradually, then rises only a couple thousand feet off the ground. And with that we see an increase in the moisture. So that's a good indicator of a frontal inversion. What do we have south of Fort Worth? Let's click on Del Rio. Del Rio is located, that's going to be down in this area. Actually, I'm way off to let me move that right there. Okay, Fort Worth is going to be up here. Del Rio is down here for those of you who are not familiar. So this is getting close to the front. So click on Del Rio. And let's see what comes up. Very tiny frontal inversion right there. There's humidity aloft, certainly. I'm not even sure that that's a frontal inversion. We should probably look at the surface maps because we do see southerly winds. Let's see here, this plot. Yeah, okay, this is a frontal inversion. You have to kind of squint and look at this, but I can see this one little plot of northeast wind right there. And that is centered right there. And that's going to be just underneath the frontal transition zone. So yeah, a very weak cold front has come through Del Rio, and above that you can see south winds at 15 knots up here. How about Corpus Christi? Yeah, how about Corpus Christi? It didn't come up. Let's try that again. Okay, we can see south winds, pretty much all layers, and a very, very shallow frontal inversion. This is probably a couple hundred feet thick. So the front has probably just come through Corpus Christi at that sounding time. And now let's go south of the border to Monterey. Now this is in the tropical air. It is showing one little plot of northerly wind, but the profile here looks very tropical. If we had more cold air aloft, I would be looking for possibly storms there. So, you know, under the right conditions, we could form up a lifted parcel that, if we had cold air aloft, that would give us a lot of cape. But in any case, that is showing we have tropical air down to the south. And let me pull this up real quick. Yeah, so this is all kind of the process of tying everything together. So we know that the front is down to the south somewhere around here. So how about isentropic lift? Where does that factor in? College of DuPage, they've got a pretty good isentropic analysis tool. It's under this weather analysis tools. And I better give you the website, weather.cod.edu. So you click on that, go to Weather Analysis Tools, and click on just Analysis Data. And then you're going to get this menu over here. And on the left side, isentropic maps. And it looks kind of complicated, but the principles here are very simple. You're looking at the pressure surfaces. Right here, there's 900 millibars. There's 850 millibars. So as we go to the top of the map here, we're going higher and higher in the atmosphere. Whereas down here, in this part of the southeast U.S., we're down at 1,000 millibars. That's close to the ground. And these levels, what are we looking at here? We've got 296, 298, 300. These are isentropic surfaces. And they're calculated in Kelvin. That's the units right there. So 294, that's going to be about 21 Celsius. That's about 70 degrees Fahrenheit. So what does that mean? This is basically where that temperature intersects the 1,000 millibar level. I'm probably starting to go over a lot of people's heads, and I'm aware of that, so I'm going to try not to confuse you too much. But it's good when you're starting out with isentropic maps to kind of tie that in with your soundings. So I'm going to make this very simple. Let's go to Fort Worth. Okay, there's Fort Worth. So let's take the 700 millibar temperature right here. You can see there's 700 millibars. What is that potential temperature at that level? It's pretty simple. We just drop this down to the surface. And where it hits 1,000 millibars, that's basically your potential temperature there. So we can see that's about 28 Celsius. Add that to 273, and that gives you your Kelvin value. So 273 plus 27, that's going to be 839303. That's going to be about 300. So if you want to analyze the conditions right here at 10,000 feet up, you're going to go to the 300 Kelvin chart. So that's pretty simple, right? And if you want to look at lower levels, the 1,000 millibar level is going to intersect a lot lower, and you're going to have a lower Kelvin temperature. So basically, the higher your Kelvin values, the higher the height. So let's go to that 700 millibar reading. Again, that's going to be about 300 Kelvin. So all we have to do is pull up the 300 Kelvin chart right there. So that's simple enough, right? And we find that over Fort Worth, yeah, that's pretty close to 700 millibars. And guys, that's pretty much all there is to interpreting the isentropic charts. From that, we're basically reading the values at that level. So we can see that at 700 millibars, 10,000 feet, the winds are out of the northwest. Now, what's really important is where the winds are blowing relative to these pressure surfaces. If they're blowing, let's see, let me pull up a good example. Yeah, look at this chart here in Mexico. So here you can see that the winds are crossing the contours. So we're basically blowing air from lower altitudes, there's 875 millibars, up to higher altitudes, there's 800, 775. So this is going to be an area of lift. Forgot to draw the arrows on there. So yeah, that's lift. This is all upward motion. And likewise, you can have downward motion. Let me find a good example of that. There we go. Downward motion right through here. So we're going from higher altitudes, there's 875 millibars, down to 950 millibars. So in the lower levels, we're going to expect to find things pretty clear in this part of the country. So anyway, you're probably wondering where this is all going. What I'm showing you here is that as of this morning, this is the valid time for this morning, things are pretty clear in the lower levels of the atmosphere, not so much in Mexico, and as we go higher, there's 800 millibars. This is going to be about 5,000 feet up. Now we're starting to pick up some upward motion as we go even higher, 300 Kelvin, 305 Kelvin. Now we're picking up some good upward motion over West Texas, and probably a bit of that is extending into Texas proper. So this is isentropic lift. It's basically overrunning over the warm surfaces. All right, there we go. That's probably about as complicated as I want to make things for tonight. So yeah, let's go into our current weather. Let me look over on see how many people I lost. Did I lose anybody here? Nope. Everybody's stuck with it. Very good. Excellent. Okay. And let me look over on chat. Yeah, I appreciate Michael letting me know that I'm sounding good. I actually do look at that from time to time on each broadcast to make sure I don't have any problems. A couple questions. Isentropic maps help you see slant in the atmosphere. Well, sort of. What this is showing you is the motion in the atmosphere, assuming no diabatic processes like heating, convection, that kind of thing. They're going to follow the isentropic surfaces. Now, that's probably a little bit confusing there, but if we go back and look at the SCUTs, the air that's at this level right here, it's going to want to cling to this isentrope that you see right here. And an isentrope is a surface of potential temperature. So what this is showing you is if the air gets forced downwards, it's going to want to sink and warm up to this level right here. If it rises, it's going to end up with this temperature here. So no matter what happens, if you force it up or down, it conserves its potential temperature and stays at 300 Kelvin right there. And when we talk about isentropic surfaces, this is a good way to think of it. This is imagine you're laying in bed right here and you're representing a cold air mass, so very cold underneath the covers. Okay, these are isentropic surfaces right here. So your parcels, you can basically picture the parcels as stuck between the sheets. They're not going to want to cross over to other potential temperature surfaces because they conserve their potential temperature. So you can picture a cat as representing a parcel. So say it's starting out right there. If the winds are blowing that cat upward, if it's blowing it in this direction to that part of the bed where the cold air is at the surface, it's going to be trapped in the sheets. The cat is going to rise as it moves over you, being the cold air mass. And likewise, if the cold air mass is on the move and you're moving to this part of the bed, you're going to bump the cat upwards. Okay, so those are two ways you can get motion. You either move the parcel with the wind flow from one area to another, or you move the underlying cold air from one place to another. Okay, so those are some things to think about. We're up to 22 minutes. I don't want to make this too long, but maybe we can do a special presentation on soundings and isentropic lift and all that right there. But anyway, what I've shown you, you can go back and view this after the video archives and kind of go over it. And I think I've got some coverage of this in my weather analysis and forecasting handbook, so you can go over that too. So I've gotten pretty far off track. Let's go back to our surface chart. Okay, I was trying to bring up the radar right here. I'm using AWIPS, and AWIPS has crashed on me, which is not surprising. It's kind of it's written in Java, and it's a very unwieldy program, but it's great when it works. So let's go straight into the forecast here. See what's coming our way. High pressure, let's see, when you join the webcast tomorrow, and it's going to be Saturday, high pressure across the eastern U.S. A little bit of warm air advection across the central plains, and cold air advection. It's almost like a semi-permanent cold air advection pattern over the eastern U.S. there, blowing that cold air southward. You all in the northeast U.S., you're probably sick of that by now, I'd imagine. Lee's side trough in Colorado up to Alberta, and here comes our next Pacific system. And you can see the packing of thickness lines very tight there in Baja California up to Nevada. So that's going to be the next cold front coming into the southwest U.S. Things are going to start getting interesting here next week. If you join us here on Sunday, now you're going to see that system moving into the plains. So there's the cold front coming out into West Texas. This would be a possible dry line storm day if we had enough moisture, which I don't think we do. I don't know, we might. I'll have to look. But this is where I would look for a dry line to possibly be set up. And back here we can see a lot of snow showers in the Great Basin area. The main surface system moves up to the north. The area down to the south is strongly baroclinic because the cold front is well down here. Way down here in San Antonio to Monterey. Warm front probably like this. And we've probably got an occluded front extending up to the north. So this here is we're probably going to see a chance of rain here. This is a Monday morning. And then by Monday afternoon, Monday evening, looks like that shifts into Louisiana. So I don't think we're going to have much severe potential here in Texas unless the system slows down. So for Monday, we're looking at the cold front coming into Texas. Storms in the southeast U.S. And we're seeing the cold air just kind of gradually oozing southward into Texas. That's a little bit strange. Usually I don't see it's kind of rare to see this troughing on the backside so far behind the surface system. So I don't know if that's a fluke in the model details, but we'll kind of watch that. But large Pacific system building in. Bringing the cold air in. And look at that 540 line coming all the way down to Dallas on Wednesday. So Wednesday should be the coldest day in the central U.S. And then we'll see that shift to the east on Thursday and Friday. Okay, so moving on to Friday. Looks like we start bringing in some new warm air advection. So yeah, this would be isentropic lift, possibly. We'd have to go to 850, 700 millibars to confirm that. But when you have high pressure like this covering the northern plains and you have cyclogenesis out to the southwest, in the southwest U.S., that's an ideal setup for isentropic lift. And that can give you a lot of precip in Texas and Colorado and New Mexico. And that precip can be wintry. And it looks like here it is, setting up for Saturday, the December 3rd. So precip from isentropic lift in Texas. Looks like it becomes pretty substantial there Saturday. High pressure staying entrenched in the Great Basin and the central U.S. And then for Sunday, December 4th, looks like that shifts to the eastern U.S. And here comes a new outbreak of cold air at the very top of the chart. We'll be keeping an eye on this. This could be an outbreak of Arctic air coming southward. The models have been pretty consistent on signaling a invasion of Arctic air around December 4th to 5th. The details have been kind of all over the map, but it's been pretty consistent in pushing a cold air mass through the western U.S. into the Rocky Mountain region. So we could have kind of a cold pattern coming up here for the second week of December. There it is, winter storm possibly coming together in Colorado. And then that'll be moving into Texas December 7th or 8th, around there. So there it is. A little bit of wraparound wintry weather on the back side of that. And this is 324 hours out, so a lot can change between now and then. And then just kind of a mild pattern, December 11th, and looks like a new storm system out to the west, so we'll keep an eye on that. All right, so I think we're about done here, and I'm going to look over the chat very quickly. And I'll just say hello to everybody, and I'm glad you were able to join me. Good to see that we got 11 people watching the WeatherCast. If there's anything you want to go over, you can email me, and maybe I can cover that in the next couple days, any special areas we want to cover. And I hope you'll join me tomorrow on Saturday evening and we'll see you then.